the series dedicated to learning C# programming from scratch. Today we will analyze our first program which we wrote in the previous lesson. So first of all, let's analyze a bit what happened when we created our first project. By default, many IDEs will add our projects to what's called a solution. A solution is actually a container that can hold one or more projects. In our case, we have a solution called Hello World, which contains a single project also called Hello World. The reason why a solution can contain and group more than one project is because we might have additional codes that would help our main application, but we don't want to mix everything up in a single project. For instance, if our application depends on plugins, it would only bring chaos to have all the codes of the application mixed with the codes of the plugins. Instead, we can add one or more other projects to our solution, in which we develop the plugins separated from our main application but still linked in some form. As we will discover later, this way we are also able to use code from different foreign projects inside our program by adding references. Now, let's talk about build configurations. A build configuration, also known as build target, is a collection of project settings that ultimately decide how our project will be compiled and built. These settings include, among other things, like the directory in which a program will be compiled, if it will include debugging information or not, if it will be optimized, the name of the output file, and others. Unless you have very specific reason to change them, these settings should be left to their default values. By default, there are two build configurations, a release and a debug configuration. The debug configuration is enabled by default when creating a project, and it is the build target that you should use while you are developing your programs. This configuration turns off any optimization and it includes debugging information, which makes your program much larger and slower, but helps a lot in the process of debugging errors. The release configuration is used whenever you are done developing your software and correct all errors and bugs, and it is aimed for the general public when the program is ready to be delivered to the end users. This build configuration does not include any debugging information and it optimizes the program for maximum speed with the least size. You can switch between these configurations either by selecting them from the drop-down or by going to the Build Configuration Manager menu. Here, you can also observe that each build configuration offers three options for the architecture for which we want to build our program: any CPU, 86 for 32-bit CPUs, and 64 for 64-bit processors. Until you have specific requirements, you should always select any CPU, which is already selected by default. Additionally, by double-clicking on Properties in the Solution Explorer tab and navigating to the Build tab, you can fine-tune the settings for each build configuration. In the application region, you can set options related to the name of your executable or the info displayed when you view the details of the executable. After setting them, we can navigate to the folder where the executable is created and see these settings applied. Let's jump to the prerequisites required to comprehend the various parts of our program. As I was saying in a previous lesson, a computer program is a series of instructions that tell the computer what to do. These instructions can be categorized into three basic elements: expressions, statements, and methods, also known as functions in other languages. The most common type of instruction in a computer program is a statement. A statement is the equivalent of a sentence in the human language. It is the smallest independent and self-sufficient unit in a language. We use statements to tell the compiler that we want to perform a task, just as we use sentences when we want to express an idea. In C#, statements are often, but not always, ended with a semicolon character. There are multiple types of statements, and here are just a few that you might find in any program. As we will learn later, this is called a declaration statement. This is an assignment one, while this one is used to output something on a screen. Expressions are the same as their equivalent of maths. They just specify a computation, a calculation that needs to be performed, And this does not refer only to mathematical computations. Expressions can be compiled by themselves, as they are meant to be used inside statements. An expression statement is composed of just an expression followed by a semicolon character. In other words, a statement composed only of an expression. Statements can also contain multiple expressions. Methods or functions are groups of statements binded together into a single unit. A method is a collection of statements that are executed sequentially. As we can see in our program, we have a method called main. Every C# program must contain a method called main. This is because when we run our program, the main method is the first to be executed, starting with the first statement that it contains. In other words, it is the execution entry point of our program. Methods are usually designed to perform very specific actions. For instance, we could have a method called print, where we put all the statements related to printing a document, and another method called save, where we store statements that perform the task of saving a file. Finally, libraries are a collection of precompiled codes, like methods, that have been packed up in a file in order to be reused by other programs. Think of them as a way to extend the functionality of programs. You may have seen at some point some files typically located in the operating system or in the installation folders of programs, ended with the extension DLL. These files are actually libraries and they contain compiled codes that are used by applications. For instance, in a game program, we could have a library where we store sounds and another one that deals with graphics. There is no need to include these codes inside the core engine of our game until we won't understand anything in a mix-up of spaghetti codes. We can just pack them inside separate libraries, which we can later call inside our programs and use them. This being said, let's analyze the structure of our program. On the first line, we have a special kind of statement called the using directive. These directives allow us to use the codes inside an external library, just as I explained earlier. In this case, we are using codes from a library named systemdll, which, if we expand the references of our project, we see that is located here. So, as we will learn later, by adding a reference to this DLL file and adding the using director to our code, we are able to use codes that are located in the system library. To further demonstrate this, if we delete the using line, the compiler will show us some errors regarding some of our codes, because it doesn't know what those codes mean anymore, since they are defined in this external library. Next, there is a blank line. This line and any other blank line will simply be ignored by the compiler. Following up, there is a namespace declaration. As we will learn at some point, namespaces help us logically group our codes in order to create hierarchies. The line underneath, it contains a curly bracket, and as you can see, when we move the cursor near it, it highlights another curly bracket, this time a closing one. Every opening curly bracket must have a closing curly bracket, or we will get compiler errors. The region between an opening and a closing curly bracket is called a block, and it tells the compiler which lines are part of the item that owns that block. You can notice that multiple blocks can be nested. On the next line, we have a class declaration, and we will learn at some point that, as in the real world, classes can be viewed as objects. We can have a class car, which is an object, another class called banana, which is also an object, and so on. In our project, this class defines an object called program. The next line declares the main method, of which I said above that is mandatory. The statements inside the block of this method are the ones that are executed first when we run our program. Finally, the next two lines define the first statements of our program. You can tell they are statements because, as I explained in the past, they end with the semicolon character. Console is a special object that represents the console, the screen of our program. WriteLine is a method that takes any text we provide to it, so it displays it on the screen. Read is a method that awaits us to press a key in order to receive an input. Both these methods are part of a console object. And with this, we conclude the discussion of our first program. As we will see in the future lessons, most of the programs we will write them now on will follow this template. In future lessons, I will explain all these new concepts in much more greater detail. Thank you for watching. If you like this video, hit the like and subscribe button. If not, c'est la vie. And see you in the next clip. Bye!